Good morning, everyone.
Good morning.
Thank you for saying I got thumbs up as well. Awesome. All right, wait a minute. Oops. Got it. All right, we're almost 8 o'clock here. You should have, hopefully already have it up, but if you don't, there's the Poll Everywhere link. You can get it up again. Go ahead and preload it. And I now have, all right, 8 o'clock AST. So let's start the daily quiz for today. So you should now see it up there on Poll Everywhere. I'll share screen so you get to see it on Zoom. So we have it for the recording. Cool, we are recording. So I just want you to calculate log base 4 of 16. I want you to calculate log base 4 of 16. All right. Cool. Good responses so far, everyone. Let's see, how many we got today? Awesome. Here's the link one more time. It's like we're just missing 8 responses. Oh, we got most people in now, so I'm going to give you all just 30 more seconds. I think we're just missing 1 or 2 now. So 30 more seconds. So I'll say 7:0 or 8:03 AST is when I'm going to lock it. All right. Good here. I like the answers that are coming through. All right, looks like I got 19. I know it's a little bit early than 7:03, but got everyone. All right, so I'm going to lock answers here in 5, 3, 2, 1. Locking answers now. All right, so it looks like most everyone got it correct. Still waiting for a couple answers just to go through. The site's being a little bit slow and you're showing me all your responses. But it looks like everyone got the correct answer, which is 2. Because if you go back to Zoom, all we need to do to calculate this is set up the question. Okay, well, what is the exponent that I need to raise 4 to get to what's inside that log, which is 16? So what we were talking about with on last Wednesday, what you got with your homework a lot. So just take log base 4 of 16. I want to figure out what its value is, which the equivalent statement would be 4 to what power then gives me 16. Now, you might remember, okay, that'd be 4 squared. Another way you can say, look at this is 16 is 4 squared. Thus, the value of my log is 2. So log base 4 of 16 is equal to 2. Okay. Like I said, pretty much everyone got it, so I think we're good, but any questions? Any questions? Yeah, some people give me thumbs up instinctively. That's what I want to see. If you're good, give me thumbs up. All righty. So today in the videos that you were supposed to watch before this, we're talking about properties of logs. We're going to be dealing with properties of logs. And the reason why we take time to go through this, it can seem like a tedious step, but these are very important. And they're what allow us to quickly solve various problems. Because remember, kind of set this up as we took our initial equation for compound interest over time. We said one of our goals would be to figure out, okay, if I invest a certain amount, I don't know, just 10,000 at some rate, I think what we did 0.055 over compounded monthly. And I want to figure out how long this would take to get to $20,000, right? My variable in this case is time. That's in an exponent. We need to have the ability to figure out what that time should be. Now, it's not on an even line because, so I see two, just by the way, I see 2 questions in chat. I see I'll answer those questions at the end of class. So I want to figure out what time is, and this is where logs come into play. So we have different log properties. And these are what we're going to talk about, the inverse of the exponents, again, solving. Okay, so a couple of our log properties. Okay, first one is if I'm adding 2 logs, there is a way that I can combine them together. So if you watch the videos, you should know this one. How is this combined together? This becomes log base b of what?
A over B.
Not a over b, but that is one of them. This one is a times b. So if I'm adding the logs together, I can combine them by multiplying by what's inside. So this rule comes from being the inverse of this exponential rule. B to the x plus y, the same thing as b to the x times b to the y. If I'm multiplying 2 exponents or exponentials together, the bases are the same, I add the exponents. When we're talking about logs, remember logs are the exponents, right? We're trying to solve for those exponents. These are exponents, so I'm adding exponents together. That's where we end up multiplying what's inside. You're multiplying the output values. Okay, so that's a nice little way to try to remember this and get the motivation on where it comes from. Because a lot of the times we do just kind of give these to you just as is and say memorize it, but this is where it comes from. It's the inverse of the statement that I have written in blue right there. Whoops. All right, that's one big log property. Another one. The subtraction of 2 logs, I can combine these together into 1 log. And then what do I get inside? Kanaya, I think you got it for me this time.
A over B.
Yeah, A over B. Thank you, Ashley. So if I'm subtracting 2 logs, this is the same thing as the log of the first thing divided by the second thing. And again, this one comes from Well, maybe write that division. If I have two things and they are being divided by each other, bases are the same, I then subtract the exponents. Remember, logs are talking about those exponents, so if I'm subtracting the exponents, that's how I get that division inside the log. It's a way of combining them. Okay, and the last one, and there's a few other ones that get messed with. The last big important one it deals with exponents. And this is our key property that in the end is going to allow us to solve a question like I have written there where I just drew that blue star beside. So if I have a log of something to an exponent, so everything inside that log is to the same exponent, I can bring that exponent down in front and multiply by it. Okay. This one comes from multiplying exponents to an exponents. If I have an exponent to an exponent, it's the same thing as just multiplying those two exponents together. And here I see that r is an exponent and the entire log is an exponent. So that's where we get this multiplication appearing from. So these are our three kind of main ones. There's other small properties that you get and you can watch from the videos. Okay. But the one thing, and what we're going to be practicing on today, is that this is an equality sign between these. Okay? These properties work both ways. If I'm adding two logs, I can combine them together into one log. If I have a single log, if I have some log of something times something, I can split it up into two logs. So we have a tendency to read from left to right, and when we do that, we always have a tendency to think that these go from left to right as well. I go from what's on the left to what's on the right. That equality works both ways. I can go from what's on the right to what is on the left. So we're going to get some practice with using these log properties. So I'm going to get y'all to go back to Poll Everywhere. And you're now going to have a new problem up. Okay, so I want you to use the properties of logarithms to expand each log expression as much as possible. In this case, I don't want to lose this, but I want you all to see it for the recording at least. Our goal is to expand log of x squared times y squared. So I just got a weird message. Give me a thumbs up if you are here and can hear me. Okay. I got a message saying my internet was unstable, so I wanted to make sure everyone is there and can hear me. Awesome. So our goal is to expand this. If you go back to Poll Everywhere, there is the link. I just sent it back in chat. So we got a couple people in right now. That's awesome. Thank you for being here and showing up. And let me go back. I'm going to leave those three main properties, those three main log properties up on Zoom while y'all work on this. Okay, expand it as much as possible. That's also going to give me time to go get my charger for my laptop. Just forgot to do that. So I'll be right back. Based on looking at these answers, make sure you're simplifying it as much as possible. There are no other log properties that you can apply. I know I got most of y'all in now. How many people we got in class now? Awesome. We actually have, I think, everyone now. Yay. So I'm looking for 2 more responses. I want to give them just a second, but I don't want to make everyone wait. So I'm just going to give you all about 30 more seconds to select your response. Oh, now we got everyone. Never mind. So give it a sec. Double check your response. Make sure you're confident in it. But I'm going to lock answers here in 5, 3, 2, 1. Locking answers now. All right, so 79% of you guys and gals got it correct. It would be that second choice. Okay, so when I look at, and you can come back to Zoom, we're going to go through it real quick. When I look at log base b, again, it doesn't really matter what this base is, of x squared times y squared, I even kind of get a cue on what the first property that I need to apply is, because I just said log of x squared times y squared. And when I go back and look at my properties, I conveniently already have it underlined in blue. I have a log property that deals with when I'm multiplying 2 things together inside of my log function. Okay? And it says, okay, if I have the log of one thing times another, so that A is just a bucket representing one thing, that B is a bucket representing another, I can split that multiplication over addition with those logs. So this becomes log of the first thing plus log of the second thing. Keep those colors together. So I can apply that with that x squared and y squared. So this becomes log base b of x squared plus log base b of y squared. Now, again, the question is, do I have any more log properties that I can apply? If I can't, then that's where I would stop. But in here, in both of those logs individually, I see that I have an exponent. And everything inside that log is to the same exponent. When I look here, I see x to the squared. When I look here, I see y to the squared. So I go back and say, okay, then what is my property for logs that deals with exponents? Well, what's this last one right here? Again, that capital A is just representing a bucket of whatever is inside of this thing. So as long as I have everything to that same exponent, I can bring that exponent down in front of the log and multiply my exponents together. So that squared for both the x and the y, I'm going to bring out in front of that log, giving me a 2 log base b of x plus a 2 log base b of y. And then again, I ask myself the same question. Are there any more log properties that I can apply to expand this thing out? Or can I maybe calculate a log? And the answer here is no. Because if I look inside my logs, right, I'm no longer multiplying anything. It's just an x or just a y. I'm not dividing anything. I no longer have exponents. Okay, so that is why my final answer when I'm trying to expand this thing out as much as possible would be 2 log base b of x plus 2 log base b of y. So, questions? If not, give me a thumbs up. But please, please, please ask questions if you got them. All right, I'm just seeing thumbs up. So one other thing I'm gonna try to harp on today, but we can always, there's multiple paths in this forest. There's multiple different things we can do to get to that same answer, just as long as you apply algebra rules correctly. So an interesting way you can go about solving this and get to the same answer is notice that both x is squared and y is squared. We have this wonderful little property. If I'm multiplying 2 things together and they're raised to the same exponent, I can distribute that exponent over the multiplication. And again, same story I'm trying to teach you with these log rules. We always write inequality. We have this tendency to go just from left to right. You can also go right to left, right? It works either way. So I could rewrite that log base b of x squared y squared as log base b of x times y squared. I could then apply my exponent property since now everything inside there has that same exponent. It's an x times y, all of that squared, which means this is going to be 2 log base b of x times y, and then just apply my last property. I see two things being multiplied inside that log together. So then I split that log up into the addition of the exponents. Let's see if I can fit it in there. Yeah. And then as we can hopefully all see, I just need to distribute that 2 through and I get the same answer that we had before. Okay. So if I go through a way of looking at these logs and it's just a slightly different method than what you're looking at, and we still get to the same answer, all is well. Okay. I wanted to go through this just to kind of reiterate that there's multiple paths in this forest. There's not one correct way to go about these problems. It's just more about getting to that last answer. Okay, so hopefully everyone's following along. Let me just go ahead and get another check. Thumbs up if you're feeling good. If not, please ask a question. All right, so I'm going to get you a new problem up there. Same prompt though. We're just wanting to expand this as much as possible. Okay. So this time I'm going to share it to the recording and I'll rewrite our properties. Share screen, yes. There we go. So our goal is to use the property of logarithms to expand each logarithm expression as much as possible. So in this case, we're looking at log base 3 of 3 times x squared divided by y to the 5th z squared. Okay, so I can already see I have multiple operations in there. I have multiplication, I have division, I have exponents. So I have a little bit more to deal with this time. But again, we just need to use those 3 properties and maybe even calculate a log. So go through and work this out and then select the answer that is closest to yours or hopefully is same as yours. I'm going to write this out in Zoom. Let me go ahead and write all of our properties again. While you are working through this. Is y to the 5th is equal. Yep. Yep. All right. Remember to ask yourselves, are there any more operations, any more of these 3 operations, expansions that I can apply to logs? What I have written down. Once you can say, no, there's no more, I no longer have exponents, I no longer have multiplication, I no longer have division, that is when you stop. So I guess while I know some of y'all are waiting, you already selected, double check your work. Just based on answer choices 1, 2, I'll go ahead and answer a question that was asked in chat privately, but it's for the entire class. And it's, do we have class tomorrow? And the answer is no, it is a university holiday. It's also part of the reason why we're only covering one section this week, which is just the material that we're covering today. So we do not have class tomorrow. It is a university holiday. All right, I'm going to give you all, let's see, where are we at now? 18. All right, so I'm going to just say 30 seconds. Look at your work. Make sure you didn't make some small mistake. Okay. Change your answers if you want to. You have 20 seconds now. Seconds. All right. Well, actually, it's much less than 20 seconds now. You've got 5, 3, 2, 1. Locking answers now. All right. So overall, good job, everyone. I think 68% got it correct or chose the correct response. But that's not everyone, so let's make sure we go through it. Okay. But when I look at this log, hopefully there is one operation that I see immediately. And it's that I'm dividing two things inside of a log. I have log base 3 of 3x squared divided by y to the 5th z squared. So then I can apply that, what's listed as my second property there, that deals with division inside of a log. So this could be log base 3 of 3x squared over y to the 5th z squared. So just rewriting it right there. And now I apply that property. That property just says take log base b of whatever was on the top, then subtract log base b of whatever was on bottom. So this will become log base 3 of what is on top, which is 3x squared. I'm subtracting log base 3 of what was on bottom, which is y to the 5th times z squared. Notice for me, the z, I put a little dash. I think some of y'all picked up on this because I've used z before. I know my 2's and my z's can look a lot alike, especially with trying to use a stylus like this on an iPad. So I always just put a little dash through the center of the z, and that just helps indicate that that's letter, not number 2. Just an FYI. Okay, but now I gotta look back at each of those individual logs, and can I expand those anymore? Yes or no? You can give me a thumbs up for yes, clap emoji for no. You don't want to speak up. What was that, Leah? Sorry. What did we say?
Yes.
Yeah, thank you. Yeah, sorry, I didn't mean to interrupt you. And I see some people giving thumbs up. Right? Yeah, I can expand this a little bit more because I see in this first log I have multiplication of two things, right? I have a 3 times an x squared. I even say it when I'm reading this off. Log base 3 of 3 times an x squared. Also have it in this second one, right? Log base 3 of y to the 5th times z squared. Again, I even say it. That's my cue, my own cue to myself that there's more properties that I can apply. So that means I can split kind of this log into the addition of the two things that I'm multiplying inside and the same thing here. Now, the first one becomes log base 3 of 3. And I got to add to it log base 3 of x squared because I was multiplying that 3 by an x squared. So let me kind of color code this a little bit nicer. This is just expanding that first log. But then I have to remember I'm subtracting log base 3 of y to the 5th times z squared. which means whenever I write its expansion, I need to subtract its expansion. So it's always good to use grouping symbols, use your parentheses, okay, especially when we're doing these expansions to make sure that I'm subtracting what this log turns into. So since I'm multiplying y to the fifth and z squared, log base 3 of y to the fifth z squared becomes log base 3 of y to the fifth plus log base 3 of z squared. But I have to remember that I'm supposed to be subtracting that thing. So I have to subtract what that expands into. Okay? And I'm just going to take a quick step, not applying any properties here, but just to rewrite what I have. Mainly distribute that negative sign through. This means I have log base 3 of 3 plus log base 3 of x squared minus log base 3 of y to the fifth minus log base 3 of z squared. So again, just didn't apply any log properties there, just rewrote what I had. Okay. So again, same question for y'all. I'm going to ask, are there any more log properties that I can apply? Yes or no? Give me a thumbs up for yes. Give me the clap emoji for no. One thumbs up. Is that everyone as well? Yeah. Not enough responses. Yep, that's absolutely correct. Yeah, there we go. Now the thumbs up are coming in. Because I see in each of those individual logs, I still have exponents, right? I can apply that exponent property, which means that this is going to be log base 3 of 3 plus 2 log base 3 of x minus 5 log base 3 of y minus 2 log base 3 of z. All right, bringing each one of those exponents out front and multiplying it by its log. And now here's the last part. Is there anything else that I can do? Thumbs up for yes, clap emoji for no. Is there anything else that I can do? Well, I got 2 yeses and 1 no's. 3 yeses now. 2 no's. All right, we're split, but I kind of wanted y'all to be split. There is one last thing I can do. It's not a log property, but it's a calculation that I can actually do. And it's that log base 3 of 3. I can calculate log base 3 of 3. If, again, I take it to that statement that we should have been practicing with the homework, it's, okay, then what exponent do I need to raise 3 to get to 3? Well, that just tells me then that my value of x, that exponent, has got to be 1, which means log base 3 of 3 is 1. So my final answer may look like this. One plus 2 times log base 3 of x minus 5 log base 3 of y minus 2 log base 3 of z. And then the same question that we should always be asking ourselves when we're doing this. Is there anything else that I can do? Any other log properties or any other simple calculations that I can do for these logs? I want y'all to answer for me. Give me a thumbs up for yes, a clap emoji for no. What do y'all think? All right, yeah, I've got enough responses. Yeah, there is nothing else I can do. I don't have multiplication of anything inside of a log. I don't have division of anything inside of a log. I no longer have exponents inside of a log. I've no longer got any simple logs that I can calculate. Thus, I am done. And that would be my final answer. Okay. So, same question as always after we're done with the example. Thumbs up if you're feeling good. If not, please ask a question. Please, please, please. All right. So, we're going to move on to the next problem then. So if you go back to poll everywhere, you now have a new problem. And how do I come back to Zoom really quickly? Sorry, if you feel comfortable with it, you can go ahead and do it. This is just a notation thing that I don't like that the book does. So I just wanted to, one, do a problem with it, and two, give you a heads up in person before you go and do the homework. So we're looking at log base 12, and we see that radical sign with a 5. And then inside the radical, we have x divided by yz. Now, radicals are grouping symbols, just similar to parentheses, right? They can group a bunch of information together. And what our book does is, instead of using extra ink to put parentheses, grouping symbols around other grouping symbols, they just leave it as kind of what you see in Poll Everywhere and what's written on Zoom. What they're really saying, there's not wanting to waste the ink for the extra parentheses, is that what is inside is that fifth root of x divided by y squared. Okay, so that is all of the stuff that is inside. It's a notation thing that the book does. Again, I don't like, but it is technically a proper thing to do. So now take it from there, work on your own. Again, same prompt. I want you just to expand this out as far as possible. Okay, expand it out as far as possible. Take your time, work through it. I'm going to say, let's see how quickly, how many responses are we getting? Only 2 so far, which is absolutely fine. I wouldn't expect too many people to get through this yet. I'm going to say about 7 or 8:40. 8:40 is when I'm going to lock answers. So give me about 2.5 minutes. All right, so we got just under a minute. Looks like most people got their responses in. Over half, I should say, just over half. So take your time, but I'm looking at the responses and they're looking real good, y'all. So I'm going to say, let's see where we're at now, 15. I'm going to give you all just 15 more seconds so we can make sure I get one more example at least before we head out for the day. So I'm going to lock answers now in 5, 3, 2, 1. Locking answers now. All right, we got most people in again. That is awesome. Way to be active today, y'all. So again, most of y'all got it correct, 65% to be specific. It would be that first option. Okay, so if you want to come back to Zoom, we're going to go through it real quick. So I have log base 12 of the 5th root of x divided by y to the squared. Now that 5th root, it's going to be very important. I got to remember how I can rewrite radicals as exponents. That's a big thing for logs, because if I can rewrite it as an exponent, I have exponent properties, and then I'll be able to deal with it. So if I'm looking at the 5th root, this means that I'm taking what is inside that 5th root and just raising it to the 1/5. Just raising it to the 1/5. So this is the same thing as log base 12 of x divided by y times z, all of that to the 1/5. And then I can deal with that exponent because I see that everything inside of this log is being raised to that same power. It's being raised to that 1/5 power. So I can bring that exponent down in front. This would be log 1/5 log base 12 of x divided by, oops, that's worse than usual for that y, but y times z. Then from there, it's going to be hopefully relatively simple now, especially if we're getting comfortable with this. Because again, I see division inside that log. So the first thing to do would be to take log base 12 of the stuff on top minus the log base 12 of the stuff on bottom. So this will be 1/5 times what this log expands into, which would be log base 12 of x minus log base 12 of y times z. Because I'm just rewriting what log base 12 of x divided by y times z is, and I got to make sure I multiply that entire thing by a 1/5. Okay. Similarly, I then ask myself this same question. Okay, anything else I can do? Log base 12 of x, not really much I can do there. However, in that second log, I'm multiplying two things together. So I can say, hey, let's expand log base 12 of y times z. So I guess I'll leave that 1/5 out front for now. So then I have log base 12 of x, and I got to be subtracting what log base 12 of y times z becomes, which is log base 12 of y plus log base 12 of z. Those match up a little bit nicer. Then just distributing that negative sign through and distributing that 1/5 through, I get 1/5 log base 12 of x minus 1/5 log base 12 of y minus 1/5 log base 12 of z. And that will be my final answer, because again, I asked myself that same question. Is there any other properties that I can apply? Any exponents inside logs? Am I dividing things by logs? Or dividing things inside of logs? Am I multiplying things inside of logs? And that last line, after I've kind of redistributed everything, I know that there is nothing else. Okay, so thumbs up if you're feeling good. If not, please ask a question. We're almost all still here too. That's awesome. All right, so let's get this last question up there, and it deals with kind of the last part of your homework that you have to do, and that thing that I've been talking about, in that these properties don't just go one way, right? not only can I expand logs, but I can condense logs. So in this, I just want you to practice really quickly for me using properties of logarithms to condense. So my goal is to get it written as a single log if possible. Okay, so go to Poll Everywhere. You're going to see the new question. I'll share it for the recording. So we want to use properties of logarithms to condense the logarithmic expression and write it to where each log expression has a coefficient of 1. So I don't have any coefficients really. Okay. So our goal is to do this for 3 times log base 9 of x plus 1 plus log base 9 of y minus 1/2 log base 9 of z. So just so I have time to talk, I'm going to give you all just about another minute, 8:47. I know that's not a lot of time to work on your own, but I want to take time to talk about it as well. So get as far as you can. And select the answer that you think is correct. Copied them correctly. Yeah, copied it down correctly. Interesting choices, people. Interesting choices. All right. So again, I wanted to give you all some time to work on your own. I know it wasn't a lot. Go ahead and give me your best guess in Poll Everywhere, and then come back to Zoom for me. We're going to work through it. Okay. So first thing to look at is that I really probably want to get rid of this multiplication. Because if I wanted to use my log properties and I can see that I'm adding and subtracting logs, notice that it's log base b of something, let's say plus log base b of another something. And that's when I can combine them together into a single log. But do these logs right here in this general form, do they have any coefficients? Am I multiplying those logs by anything? Well, the answer is no. So if I want to take advantage of this property for addition or the other one for subtraction, I have to make sure that the logs, before I combine them together, don't have any coefficients out front. So when I'm looking at this, I can see that, hey, I might be able to combine the first 2 logs, right? That might be where your eyes naturally float. Or you might say, hey, I'm looking at these second 2 logs, and I might be able to combine those together as well because I'm subtracting. Okay. But before I do either of those, I have to notice at least 2 of those logs I have exponent or coefficients. But those coefficients I can turn into exponents because we said log, oops, let me use capital L, log base b of anything to an exponent. I bring that exponent down front and multiply by it. That's reading it from left to right, but all of these can go the opposite way. If I have a number times a log, I can then write everything inside of that log to that number I'm multiplying it by. It becomes an exponent to everything inside that log. So that log, or 3 times log base 9 of x plus 1, that's going to become log base 9 of x plus 1 to the 3rd power. I bring that coefficient and make it the exponent for everything that was inside the log. Everything that is inside the log is x plus 1, so it becomes x plus 1 to the 3rd power. For that log base 9 of y, I've got nothing there, right? I've got no coefficient, so I'm not going to be applying this exponent property here at all. But then I have on that last term, I have a 1/2 that I'm multiplying by. So again, I do that same idea with the exponent and bring it in, and it becomes the exponent for everything inside. So that 1/2 log base 9 of z is this becomes log base 9 of z to the 1/2. Now I have just logs, and I can start combining things together. Naturally, these are the first two logs because we reliked right to left, left to right. So I'm just going to combine them together. I'm adding the logs, which means I'm going to then, when I combine them into a single log, multiply the insides together. So this becomes log base 9 of x plus 1 cubed times y, and then I'm still subtracting this log base 9 of z to the 1/2. Let's see what time it is. So we're going to just make one observation, just how we write it based on the answers I gave. Raising something to the 1/2 power is the same thing as the square root. So this is that last term. We're not, in this last line that I wrote, I'm not applying any log properties. I'm just rewriting how I see z to the 1/2. But then I just see either way whether or not I left it as z to the 1/2 or I rewrite it to the square root of z. And now see I'm subtracting two logs. The bases are the same, which then means I divide what is inside. This becomes log base 9 of what was in the front. So what was first, which is x plus 1 cubed times y. And I divide it by what I'm subtracting from the inside of from what I'm subtracting, which is the square root of z. So now I have this all into one log, right? It's log base 9 of x plus 1 cubed times y, all divided by the square root of z. So that would be your final answer. It's all inside of one log, and I have no coefficients outside of my logs. Okay. So questions, if you have them, thumbs up if you're feeling good. I'm just seeing thumbs up. All right. Well, if you got no questions for me, we are out of time, so you are free to go. Like I said, there is no class tomorrow. It's university holiday. So next time we meet will be next Tuesday, a week from today. And I'm not sure if y'all are aware, but we're kind of in the final stretch. Next week is our last full week of classes. In 2 weeks, it would be our last day that we actually meet for this course. So we are almost done. We're almost there. We somehow survived. Okay. So again, if you're feeling good, you're free to go. If not, you're welcome to stick around and ask a question or two. I'm going to go ahead and stop the recording now.